The difference in the ellipse and the circle is that the circle has equal coefficients. We've learned that if you have an x squared plus y squared equals 1, that would be the most simple form of a circle where the coefficients are the same. It has no offset from the centering. It's at the origin with a radius of the square root of 1, which is 1. So it would be a circle centered at the origin with a radius 1 all the way around like that. And then we learned that sometimes the centering is off from the origin, maybe like this. So the center would be positive 3, positive 2, over 3, up 2. And then the radius, I picked 1 again, but the radius could be whatever over here, positive number, that's the radius squared. So the square root of that would be 1. You'd go 1 away from the center, all the way around it, you could draw your circle. But anyway, what I want you to know is with the circle, the coefficients in front of x squared and y squared are the same. So if this were expanded out, FOIL this and FOIL that, and you saw it in its expanded form, what you would notice is 1x squared plus some stuff and 1y squared plus some stuff. And that's what would clue you in to expect a circle. All right, so look at this. This looks like a mess from the beginning from that. So what we want to do is be able to recognize the expanded forms and say, I wonder what figure I should try to get that in the form of. And so what clues me in to look for an ellipse, the x is squared and the y is squared. Now I also have an x to the first and a y to the first, but you go by the biggest exponent when you determine what type of figure it is. So the biggest x is squared, the biggest y is squared. Their coefficients are different but positive. So they're positive, which means they're going to come together. On the circle and the ellipse, you have positive x squared and y squared. So anyway, ellipse because the coefficients are different though. So I'm going to save this one to last. This is like worst case scenario, how you clean that up and find its graphic form. But before we do that, let's start with just the general form of an ellipse. This is the general standard form you want to get your ellipse in to graph it. Because the coefficients are not the same, we wind up having a fractional amount under it. You know, it winds up being in a fraction form, and we work from the other side, making the constant equal 1. So what we'll do for an ellipse is we'll get x squared over something plus y squared over something equals 1. That's the standard form for the ellipse. Where the centering, if there's a plus or minus something on it, then that's the offset for the centering. And the number under x is something squared. So we'll square root it to see how far we traveled out from the center in each direction. So you square root this number under it, and that's how far you move each, kind of like the radius idea. You move from the centering on the x-axis. Under the y term, you'll also square root that number, and that's how far you go up and down from the center. All right, let's see that in this example 1. All right. Why I think this is an ellipse is x is squared, y is squared, and these would be considered different coefficients, like 1/9 and 1/4. So different coefficients, but it's still plus. It's already put into the standard graphing form. This has a centering that is moved to positive 4, negative 1. You know, guys, everything we've done, every formula we've used has had a negative sign in the parenthesis, and that's why we're always changing these signs. If it's grouped in a parenthesis, you're using the opposite sign. So for the center, it's over 4, and that would be down 1. Okay, so the centering is at positive 4, the x shift, and negative 1, the y shift. Now remember what's under the x, because these could be written in the other order. So what's under the x is the x movement, kind of the x radius of sorts. It's not a true radius because it's not a circle, but it's like we did the radius idea. That's how far we move from each side of it. So that number represents the number squared. Remember in the formula, that's the a squared value. So you'll square root that to find a is 3. So that means you'll go over 3 and back 3 from the center. So how far are we going up and down? What do you think? So the square root of that one, which is 2, and that's how far you're going to move up and down and that's your ellipse. Okay, let's try it again. Let's say another one that's already in standard form. Standard form has it equal to 1. Remember, for standard form for an ellipse, because the coefficients are different, we have to make the end number equal 1. So it's already in that standard graphing form. The center is at -1, +2. So back 1, up 2. Under the x, we square root that number, which is 4, and hopefully these numbers are nice numbers. If it's not a perfect square, you'll have to get your calculator to give you an estimate. But square root of 16, which is 4, is how far you go each direction on the x-axis. And then under the y, the square root of that is 5, so you'll go up and down from the center by 5. And then draw that in, and that's your ellipse. We call this distance would be a total of 8. We went 4 each way. That would be called the minor axis of your ellipse. 8 units. The major axis, 5 and 5. The major axis is 10. If you're asked that question, list the major and the minor axis distance. If you're asked to give domain and range, it has definite stopping points. You know, we started at back 1 and then we went back 4 more. So we went back to -5 and then over +4 from -1, it went over to 3. So you can count how far it is left to right on your graph. And so your domain would be, and we would use brackets because it touches those spots, -5 to 3. And then we could do the range, see how far down to up you are, and list the range as well. All right, so I told you the last one I do is one where you have to complete the square and do the whole ordeal to find the graph of that. All right, I suspect this to be an ellipse because I have an x squared and a y squared. So I want to clean that up, put the x's together and the y's together. And I want the constant over on the right side. All right, so I want to complete the square to try to find the centering, just like you did in the circle. But this time, I can't just divide through by the coefficient like I could with the circle because I have a 4 and a 9. I can't divide by one of those. It wouldn't take care of my issue. I need both of those to be 1s in front. So here's the strategy. Factor the 4 out of the 2x terms. Leave a space to complete that square. For the y's, we factor the 9 out. Leave a space to complete that square. The reason I'm doing that is you're not allowed to complete the square unless the coefficient of the square term is 1. So I had to bring the 4 out of it, and for the y's, bring the 9 out. Then half of this term, half the middle term squared would be 1. So I will add 1 to make that factorable. It was actually times by a 4. It has a weight of 4 out there, so you've got to incorporate that. 4 times 1, so you added a real 4 to the left side. So I will have to add 4 to the right side to keep the balance. So you can have, you know, some of the equations we try to avoid adding to the other side, but this one you can't. That factors into 4 times x minus 1 to the second. Then for the y's, we half the middle term, which is 3. 3 squared is 9. That completes that square. It has a multiplier of 9 in front, which means there was actually an 81 added to that side. So we'll add 81 to the other side to keep the balance. Now that factors in y plus 3 to the second. Negative 49 plus 4 plus 81 is that 36? And now we're making some progress. At least we've got it cleaned up. We've completed those squares like you do in a circle. Here's the difference from the circle, though. I can't, the difference in this and the circle is I need to make it equal 1 on this side. Standard form looks like this. It equals 1, and I have stuff under the x and the y's. So I need to get rid of this 4 and this 9 and make that 36 a 1. So what I will do is divide, after you get the squares completed now, this is this step along, then you divide by your constant. Every term, you're dividing each side by 36 to keep the balance. That makes that equal 1 like we needed it to. And this reduces to a 9. So it's x minus 1 squared over 9. The 9 and 36 reduces to a 4. And now it's in that graphing form, and most of your homework, maybe all of your homework that I assigned is already in this form, but we do need to know this. I know on the final study guide we have to do this at least once on the study guide, so we need to be familiar with that, and we'll go over it again when we start reviewing. But from this point, now it's ready to graph. The centering, the starting point is 1, negative 3, so over 1, down 3. Under the x, the square root of that is 3, so I move 3 each way. Under the y, that would be the square root, it would be 2, so I go up and down by 2's. Because it's plus, it comes together as an ellipse. And that's your final graph. All right, any questions on that?